all, my name is Rahman and welcome back to my YouTube channel. So guys, in this video I am going to give the introduction to the main shift in the machine learning. So guys, in this video on the topic of the clustering itself, I am going to talk about the main shift. Up to this point we have been talking about the k-means, we also talked about the flat clustering, and just we have referenced the hierarchical clustering. But guys, if you remember in the last video we have started the k-means from the scratch, and then in that video only we have ended up there itself. So guys, in this video I am going to give the introduction to mean shift in the machine learning. So guys, you know that as I said before, in the machine learning there are two types of clustering. One is supervised and another is unsupervised. And in the starting itself, in the starting of the k-means tutorial, I have talked about the hierarchical clustering and the flat clustering, right? So up to this point we have talked about the flat clustering and k-means algorithm, but guys, we didn't talk about the unsupervised clustering like hierarchical clustering, and we also didn't talk about the main shift algorithm. So guys, in this video I am going to cover all of those stuff. So guys, first of all guys, here we have a question that what is mean shift? It's a shift in the machine learning. Mean shift is a hill climbing algorithm which involves the shifting this kernel iteratively to the higher dynasty region until its coverages. Every shift is defined by a mean shift vector. The mean shift vector always points towards the direction of the maximum increases in the destinity. And guys, in other words, you can also say that we have a question that what is mean shift in machine learning, as I said before. Now, in other words, you can also say that mean shift is an unsupervised clustering algorithm that aims to discover blobs in a smooth density of samples. It is a centroid-based algorithm that works by updating the candidates for the centroids to the mean of the points within a given region, also called as the bandwidth. So guys, I am going to talk about the what is mean shift. So guys, right now we have just talked about what is mean shift and all of those stuff, right? Now guys, let's talk about like how it works, like why it is used and all of those stuff. So guys, we have another question that why is mean shift used in the machine learning? Why it's used only in machine learning, right? Because mean shift is widely used in the real world data, like for example data analysis and image segmentation. It is used because it's non-parametric and does not require any predefined shape of the clusters in the feature space. In the k-means, this is the mean shift, right? But guys, in the k-means, what we need is shape of the clusters in the feature space. All of those stuff we need, right? Now, in this mean shift, we don't need those kind of stuff. Now, we have another question that how does mean shift algorithm works in the machine learning, right? How this clustering works? Mean shift algorithm has applications in the field of image processing and computer vision. Let's say that given a set of data points, and then the algorithm iteratively assigns each data points towards the closest cluster centroid and direction to the closest cluster centroid in the determined by where the most of the data points are nearby at them. And now guys, one more thing I forgot to tell you is that in this video I am going to implement these things with the Python in the Jupyter lab. Okay, so first of all guys, I am going to show you that, as I said you, how this works, right? So first of all guys, I am going to show you like how it is going to work with an example. Okay, so guys, let's go ahead and get started by doing that. First of all guys, let's say that we have a graph, something like this. We have a graph, something like this. And guys, in this graph, we have some of the data points. Let's say we have the data points at this point itself. We have a lot of data points here, and also here we also have a data points in this case. But guys, what we does is in the flat clustering, what we do is we say that, let's say we want k equals to 2. How many clusters we want? We want these two groups. So what we does is we make this a group, and then we make this also a group, right? But guys, in the hierarchical clustering, what we say is, let's say the computer says that it chooses, and then we say that okay, we should use this one, so it gives us the suggestion. Okay, so guys, what this computer says, let's give it as 3. Okay, and then what we do is we give something like this starting from here. We give something like this starting from here and here, and then we have these 3, right? It's pretty much simple. But guys, what happens is, what does this mean shift does is, like For example, we have a group of dots that you are seeing on the screen. Now we have this group of dots, and what it does is it searches for the dot, which it searches for a data point which has the more number of clusters, which have the more number of data points closer to it. Like for example, let's say that we have these two, okay, and then beside this we have this data point, and near to it we have these data points 1 2 3 4, okay, but guys here also we have only 3, so it's just for something like that. And guys, you have this one, right? Then it's going to cluster this group, something like this. It's going to do all of this kind of stuff. Now guys, as I said, I am going to talk about the bandwidth, like radius. So guys, in the machine learning, let's say I'm going to clear all of these dots. Now guys, let's say we have some of the dots. Let's use some here and here also. Now guys, you have this one. Now what we say is, let's say that this each of them is a centroid. This is also a centroid. This is also a, or let's choose this one. This is centroid. This is also a centroid. Okay, and then guys, we have this one, and this one. So guys, all of them are the cluster centroids that we can say here. But here these are also. So guys, we can give all of whatever we want. So I have just taken an example of this one. Now guys, we have another step, which is to take care the radius. That is radius. Okay, or people also call it as the bandwidth, which is also called this as band. Now guys, we don't need all of this stuff right now, so I'm going to talk about this later on. First of all guys, I'm going to implement these things with the Python in the Jupyter lab. So let's go ahead and get started by implementing that on the Python. Now so guys, as you can see here on the screen, I have already imported these libraries and I have returned all of those code for implementing this with Python, right? So guys, there is no much to write here, so I have just written all of these already. And guys, I have here already all of the things are same, but here these two things are new. The first one is from matplotlib. Dot toolkits. I'm importing here the matplotlib 3D. I'm going to import here the 3D graphs. So guys, in this is the first video where I'm going to create the graphs in the Python. So just we have already imported these things. Now let's run the first one. Okay, so guys, we got this one. So guys, it's running still. So I just run this one and then restarted the kernel. Now we have the style that we are going to use here. This is this one, and guys, you have the centers that you want to come, like at which point this all of this stuff to come, and we have the make blobs, like they are going to make here the all of the blobs. And then let's run this one. You are going to get the output that you are seeing on the screen. Okay, so you can see here the guys, the stars that you are seeing, or instead of this one where was I here, instead of the stars, I can also give here these x, or not x, I can also give here these o or something like that. But guys, the interesting thing about here is that we can move this graph if I run this in the ideally of the Python. But guys, in the Jupyter lab, it's not going to come all of the stuff. So if I copy, if I save it, okay, now guys, I have already created a file in the ideally here, which is this name. So let's run it with the Python in the VS Code, or let's check whether what is it going to come or not. Let's run it. It's going to run here right now, I think. Okay, so anyway guys, let's do one thing guys. I'm going to open here the folder itself, so which is machine learning with Python. Okay, now let's open that file. It was the py file, because all of these files are this name.py, right? So I just created just for sample only. Now let's run it. Here we are getting some errors like pip install the sklearn. We are going to install this one, and I'm going to install it in NumPy, and all of the stuff it's going to install here right now. So guys, till the time, okay, now let's install again. Pip install. I'm going to install here the matplotlib. Let's install all this one also. sklearn is being installed using the, okay. Now guys, let's check whether is it installing or not. Guys, it's still installing. Now guys, I have to install it again. Okay, so guys, I have already installed it in NumPy. That's why I am not getting any errors right now. Now sklearn could not be resolved. We are getting this error, right? So anyhow guys, let's do one thing. Let's run all of those stuff here right now, and let's see the problems that we are getting here right now. So anyhow guys, this is also running right now. We can also use this one. So I think I should close this one and reopen it. Here we will write this name.py. Okay, now I think I am not going to get errors for the matplotlib, but guys, I am getting the errors for the sklearn. So let's create a new one. Okay, now guys, let's install here the pip install the sklearn requirement already satisfied. Right now we are getting. Okay, so anyhow guys, now we are getting here the errors, or if I reopen it, I'm going to get errors or not. Let's check with that. Okay, so anyhow guys, here we are getting the errors also. Let's check these all of those stuff later on. Now till the time, what I'm going to do is I'm going to cmd, and then I'm going to install pip install the numpy. Okay, I'm going to install the numpy, so it's already satisfied. So I'm going to install the scikit-learn sklearn, and then after this one, default user instruction because not writable. Okay, now guys, here I am getting the site packages. Let's copy this one. Okay, so anyhow guys, let's install the pip again. Pip install the matplotlib. So let's install this also, and then guys, let's open this file with the IDLE Python. Now guys, it's going to open right now in the IDLE of the Python. Till the time, I'm going to wait here, but guys, this is the anaconda, and this is for the okay. So it just ran right now. So guys, it's going to open with the IDLE. Let's open from here, IDLE Python. Okay, let's open this one, and guys, let's open the file from here, and we have the name .py, and then guys, let's run it. So we are going to get errors, no module named. Let's install the pip install sklearn. Pip so anyhow guys, let's leave that one. So I'm going to show that later on. So anyhow guys, it's going to come in the graph and all of the stuff. So now guys, I wanted to show you like how it's going to work. For example, we have the numpy on all of the stuff, and guys, we have given the centers, like at which point it should come. So if I open the image in the new tab, and the image that you are seeing here, okay guys, we have the dots, and guys, if you see here, up to this point we have drawn the graphs but not the 3D graphs. So guys, normal graphs will be something like the plane. If you watch my previous videos, then it will be a lot more different than this one, because it's going to come like a box. Okay, and those will just come like a boxes that you see in the Max book. Okay, so anyhow guys, we are getting the number of estimated clusters that we are getting here is 2 here and here. And guys, if I give here around the 1000, then guys, these dots are going to increase. Okay, so it's still running. Let's see the output, what this is going to be. Now it's creating here, it's still creating here the graph. So guys, as you can see here, we have the number of clusters is 3 because we have increased the value from the time we're getting this number of clusters is 2. Like for example, if we give it to the somewhere around here, then guys, it's going to take a lot of time. So let's wait for this some time. Okay, and then till the time I'm going to explain you like what I have written in the code. So here we have the ms equals to this one, and then guys, classifiers that we are passing here, and we have the labels ms dot labels, and we have the cluster centers. So guys, as you can see here, we have the centers for the clusters, right? And then guys, we have the given something like print number of estimated clusters that we have created. Okay, so guys, how many we are getting? Like for example, if you see sometime before that we are getting the number of clusters is 2, something like that. And we have the colors, which is going to be 10 into, we are multiplying 1 2 3 4 5. So anyhow guys, we have to do this with the, and then we are drawing the figures here. Like we have the plt.figure plot, and we have the ax figure and subplot 113 okay, and then we have the projection. We have to 3D, or in this case here, let's go back. Okay, so anyhow guys, here we are getting the lot of even, so this was my mistake. One more and run it. So let's continue to explain about this one. Now after this, I have given here the ax, which is going to be equal to figure, which is going to be figure, and it's equal to, and subplot you have done, and the projection that you have done here is the 3D. So we can give here the 2D, 1D, or anything else. So now we have the for I in range length x we have, and we have created the value of x. Here we have the right, and then guys, we have the for I in range length x, and then we have the ax dot scatter, and we have the xi into 0, which is going to be the index 0, and then we have the index 1 and index 2, and then we have the c equals to colors, the labels that you have made, and that I have the marker, something like this, right? And then guys, as you can see here, we have the scatter, we have the cluster centers, as I said you by explaining some time before, and then you have the cluster centers, which is 1, the cluster centers 2, and then we have the marker is x, the color is black, and we have the size around 150 of the markers. So guys, at the dots you are seeing two big marks like XX, right? Because, so guys, that you are seeing because of this bigger size like 150. If I give it to 200, then guys, it's going to be very bigger, okay? And then guys, you have the line widths, like how much bold it should be, and then you have the set order, and then guys, finally we have given something like plt.show and all of those stuff. But guys, up to this point I have explained all of these things, but guys, it's still running. The interesting thing over here about is that it's still running, because here I have given ones, tens, hundreds, thousands, and lakhs. So 1 lakh dots I have given something like that. So anyhow guys, it's going to take a lot of time. I didn't also counted these numbers, right? Like n samples and number of samples. So here you have the np.unique. So guys, as I said you, what is the use of unique in the machine learning and in the Python also, as I said you. So anyhow guys, that's all for this video. I hope you liked this video, enjoyed watching this video. Thank you for watching this video, and guys, I will see you in the next tutorial. Thanks for watching. Thank you. Bye.